Yes, so hopefully everything is good and I am visible also. Let me check the, yes, it is okay. Yes. So we had learned up to here. This is basically lecture number 5 of physics optional paper 2. Okay. And it's my promise. Okay. It's my promise. It's my gentleman promise that I will give you 100% coverage of physics optional syllabus. Okay. 100% coverage of physics optional syllabus I am going to give you. You need not join any class for physics optional. Okay. 100% physics optional coverage I am going to give you. That is my promise. Okay. And you won't find any other class covering this much. Okay, even paid class won't cover this much. I am going to give you 100% physics optional coverage. Okay, so no need to, and it is my promise that I will complete the syllabus before prelims 2023. Okay, I am going to cover the syllabus before prelims 2023. Means I will cover the syllabus in the month of January 2023. Okay, January 2023 I will complete the syllabus of physics optional. That is my promise to you. Okay, that is my promise to you. Okay, and I don't break my promises ever. My students know this very well that I don't break my promises ever. Okay, so 100% coverage before prelims 2023, and not like one day before the prelims I am covering the syllabus, not like that. Okay, January 2023 will be your this physics optional syllabus will be over. Okay, and one more thing, so no need to join any other classes for physics optional. Only thing is you need to join test series. Okay, you have to join, you should join test series for physics optional. Okay, you should join test series for physics optional. Okay, you should join test series. But I am also taking test series, but I am taking in online mode. Okay, you have to make the PDF and send me the answers, like that I am taking. Okay, so I am taking only in the online mode. So if someone wants to sit in the classroom and give the test series, then I also take the test series in offline mode. But the problem is that all the benches are full. Okay, only 30 students I take. I only take 30 students in offline mode, and the rest of the students are online ones. Okay, so all the benches are fully occupied in the offline test series mode. Okay, so basically I take 30 students of each optional. 30 students of physics optional, 30 of chemistry optional, and 30 of maths optional. Like that I take. I am basically PCM expert. Okay, although I teach other subject also, but I am expert in PCM. Okay, so that's the thing. So let's and today's stars, I would like to tell the names of those stars. Today's stars are what her name is Khushi Daksh, I think. Okay, not Khushi Daksh, Kusum Daksh, sorry, Kusum Daksh. Okay, her name is Kusum, and she liked my videos. And one more person is there with the name A plus science classes, I think. Okay, A plus science classes. So these are today's stars. Okay, thanks to these people for giving me the love. A plus science classes. Okay, so these two people's, I don't know what is the gender of this person, but these two persons are thanks. I am thankful to this person. Okay, thanks a lot. Okay, so let's move on towards our next topic, that we had learned up to here, right? That phase velocity is a half of particle velocity. Up to here we had learned in the previous class that phase velocity, let me write over here, phase velocity is half of particle velocity. Okay, up to here we had learned in the previous classes. Okay, Vp equal to V by 2. Now we will learn the wavelength dependence of Vp. Okay, and if someone of you has directly come to this lecture number 4, then no, it is lecture number 5, I think. Okay, So the initial 4 lectures they can watch. Okay, I have pinned the link of the playlist in the description also, and the link is there in the comments also. Okay, so you can go to the playlist and watch it from there. Okay, and if someone of you wants to join the online test series, okay, if someone wants to join online test series, then they can just message me over here. Okay, whatsapp whatsapp. Okay, okay, so for online test series you can contact me on whatsapp, and we will start the test series from basically uh, every student is in different stage of preparation, but we will start the test series with classical mechanics and quantum mechanics. Okay, paper 1 topic number 1 and paper 2 will go on simultaneously. Okay, paper 2 will go on simultaneously. Paper 2 will start from quantum mechanics. Okay, and this will start from mechanics of rigid bodies, mechanics of continuous media, etc. Okay, so in short, classical mechanics. Okay, the test series will go on like this, and what are the details of it? It is basically paid. Okay, online test series is basically paid one. Okay, but the fees is quite low, don't worry. Okay, so you can contact me if someone is interested in the test series, but only those students should give the test series. Only those students should give the test series who have completed the syllabus. Okay, those who have completed the syllabus na, only they must give the test series, completed syllabus people. Otherwise it will be difficult for them to manage. Okay, so that's the thing. So wavelength dependence of VP, let's start. Wavelength dependence of VP. Okay, VP means phase velocity. Okay, so wavelength dependence. So VP equal to V lambda. Okay, nu lambda. Okay, so this is wavelength dependence of VP. VP equal to nu lambda. Let this be equation number 1. Okay, and now mu equal to what? E by h. Okay, you know this very well, na? E equal to h mu, right? E equal to h mu. You only see, na? E equal to h multiplied by mu. So E equal to h mu. So according to Planck's formula, h mu equal to E. So bringing h on the left hand side, right? So this is the formula. So now Einstein gave the dependence of energy and momentum and energy relation. Einstein gave, and that relation was like this. Okay, p square c square plus m naught square c to the power 4. Okay, so uh, like this. Okay, this is the thing. So you know this very well, na? That you know this formula. That what is the formula basically? Formula is like this, na? E square equal to p square c square plus m naught square c to the power 4. The formula is like this. So you will take the square root on both the sides, right? So accordingly you will get that. Okay, so this is the thing. So you got that. So divided by h. Okay, now this thing divided by h, and then mu equal to this c square, just put this common. Okay, this c square, take it out of the, what do you mean by power half? Power half just means that it is square root. Okay, consider it like square root. Power half means square root only, right? So it is square root. P square c square plus m naught square c to the power 4, right? And this is divided by h. Okay, so c square will be put out common, so c. Okay, p square. Okay, this c square common, So if you take the c square common out of the square root, then it will become c. Okay, it will become c, m naught square c square, right? So divided by h. Okay, so this is the thing. So you can eventually write this as mu equal to c by h. Okay, p square plus m naught square c square power half, because the square root is power half only, right? Square root is square root. What is the square root? Square root is power half only, na, right? So this is the thing which you got. Okay, and you know this very well. Let this be equation number 2, and if I have marked that, yes, that has been marked as equation number 1. So now lambda equal to h over p. Okay, you know this very well. And let this be equation number 3. Consider this to be equation number 3. Using 2 and 3 in 1. Okay, use these two equations 2 and 3 in equation number 1. Okay, to use these in equation number 1. Okay, so using 2 and 3 in 1. Okay, we get. And don't worry, yeah, if someone or some of your friends want to study chemistry optional or maths optional, so I will launch their course also on the YouTube. But after I complete the physics optional course, okay, after the physics optional course is completed, after that I will start maths optional course, and after that I am going to start chemistry optional course. Okay, so don't worry about it, you will get everything. Okay, so if some of your friends or brother sister anything, if they are in need of such courses, they can surely join the see the lectures and take the benefit of it. Okay, so vp equal to your, okay, c by h p square plus m naught square c square power half. Okay, how did this come? How did this come? You only see, na, you know this very well that vp equal to mu lambda. Okay, so value of mu is this. Okay, value of mu is this, and value of lambda, what is it? What is the value of lambda? Value of lambda is this. Okay, so you will put these two values in this. Okay, this value, this value, and the, I mean this value. Okay, both are same, na, square root. So this value and this value you will put in this equation. Okay, so ultimately what you will get is there on the next slide. Okay, so keep writing along with me, your all notes will be ready. Okay, your all notes will be ready, and don't be offended if someone of yours name is not taken by me. Okay, some for example, I didn't take the name of Rishav Kumar, I think. Okay, I didn't take the name of Rishav Kumar, but don't be offended. Okay, I take everyone's name, I respect each and everyone, but those people were the ones who liked the videos very much. Okay, those were those people. Okay, so that's why I am thankful to them for giving me the love. Okay, so this is m naught square c square. Okay, so h and h eventually cancel out, right? So and then you will take this p which is out of the square root inside the square root. Okay, so you will take this p inside the square root. So when you take it inside the square root, means power half, you will have to square it in order to take it inside the square root. Okay, so you took it inside the square root. Okay, then what will happen? Then ultimately you will write this to be equal to, okay, c 1 plus m naught square c square divided by p square, right? And to the power half. Okay, so ultimately what are you getting? And then final step, one more step is remaining now. Okay, so most of your question paper of physics optional is mechanical only. Okay, you don't have to worry, it is mechanical. Okay, so m naught square c square. Okay, divided by p square, okay, power half, okay. So this is the thing, and p equal to what is p h by lambda, right? You know this, na? P equal to h over lambda, okay. How did this come? You know this very well, right? Lambda equal to h upon mb, na? De Broglie formula, right? You know this very well, right? mv equal to h by lambda. So lambda is equal to h by mb, okay. So you, from this we got this, okay. So now we will put this value of p, that is h by lambda, in the above equation, okay. So just put this value in the above equation. So when you put this value in the above equation, what will you get? 1 plus m naught square c square, okay, divided by uh, h by lambda, p equal to h by lambda, so h square lambda square, okay, power half, okay. So now you, this relation is very very much important. You have to remember this formula. This formula you will have to remember, okay. You, this formula you will have to remember. Remember this. Remember. Remember, okay. So Vp equal to this. Now you clearly can see this now over here, that Vp isn't it a function of lambda? Isn't Vp, your phase velocity, isn't it a function of lambda? Yes, it is a function of lambda. Now someone will say, sir, it is a function of c, m naught, h and lambda. Okay, someone will say, what will someone say? Someone will say that it is a function of, okay, someone will say that it is a function of m naught, c square, h square, c. Okay, so someone will say like this, it is a function of c, m naught, h and lambda. Someone will say like that. But this is wrong concept, na? Why it is wrong concept? Are constants ever taken as a function? This m naught is going to be constant, okay. Your particle is fixed. Your particle or wave is fixed. So m naught will be a constant. Velocity of light c is a constant. H is a constant. Planck's constant. C outside c is also a constant. Only the variable thing is lambda. Lambda is varying, okay. So isn't it a function of lambda then? You only tell me, if a function is like this, f of x comma y equal to c x square plus y square, if a function is like this, so do you call it function of c x and y? Do you call it function of c x and y? No, you don't call it function of c x and y. Why? Because it is c, it is constant, right? So in the similar manner, only variable thing is lambda over here. C, H, M naught, C, all these things are constants. So obviously it is going to be a function of lambda. Okay. So your Vp is a function of, Vp is a function of what? Lambda. I can write like this. Okay. So it is a function of lambda. Vp is a function of lambda. Now what does this imply? Okay. So I am writing over here, if this is going to come in paper 1, but for the time being, just remember this, okay. If Vp comes out to be a function of lambda, if Vp comes out to be a function of lambda, then the medium, okay, is dispersive medium for that wave, and if it doesn't come out to be a function of lambda, then medium is non-dispersive. Okay, so the meaning of this is very clear now. Okay, here what are we calculating? We are basically finding out the wavelength dependence. Okay, we are finding out the vp in terms of lambda. Okay, means wavelength. Phase velocity is being found out in terms of lambda, means wavelength. Now as phase velocity is being found out in terms of lambda, that is wavelength, you only tell me for a dispersive medium, uh, dispersive medium is defined as such a medium in which the phase velocity is a function of lambda. Let me give you an example. Okay, if you substitute uh, value of m naught equal to 0 over here, if you substitute the value of m naught equal to 0 over here, what will you get? After you substitute m naught equal to 0, for which particle m naught is 0? For a photon, rest mass is 0, right? Rest mass of a photon is 0. So if rest mass of a photon is 0, so m naught value will be 0 for a photon. So m naught value is 0 for a photon. So this term is going to vanish. Okay. So only thing which will remain is Vp equal to C for an electromagnetic wave. Let me write in the next slide. Okay. Okay. Let me write over here. The quantum so yeah, over here write one remark before writing this. Okay, write one remark over here before writing this. Okay, the free space, the free space is a dispersive free space is a dispersive medium for de Broglie wave. As phase velocity Vp comes out to be a function of lambda. Okay, so that's why free space is a dispersive medium for de Broglie wave. But what about electromagnetic wave? What about electromagnetic wave? What is the case of it? Okay, so you found out that Vp equal to, okay, C into 1 plus m naught square C square lambda square divided by h square. Okay, power half. Okay, you found out this, right? Now for a de Broglie wave, de Broglie wave means what? De Broglie wave means matter wave. De Broglie wave means matter wave. Okay, de Broglie wave simply means that matter waves. And matter waves have rest mass, some rest mass. Matter waves always have some rest mass, right? Because matter waves consist of particles of matter. Okay, particles of matter. So it will have some rest mass, right? So will this term vanish? Will this term vanish? No, it will not vanish. Okay, it will not vanish because m naught has some finite value. But what about electromagnetic wave? Okay, but what about electromagnetic wave? M naught equal to 0 for electromagnetic wave. Let me write over here. Okay, m naught equal to 0 for electromagnetic wave, because electromagnetic wave consists of photon. Okay, for EM wave. So Vp will be equal to C. You only tell me, na? You only put the value of m naught over here. Okay, so this term will vanish. Okay, Vp equal to C for a electromagnetic wave. Then let me write on the next slide. Okay, let me write on the next slide. Vp equal to C for EM wave, because EM wave consists of particles called as photons with rest mass m naught equal to 0. So photons have rest mass m naught equal to 0. So obviously your Vp according to this formula, what will happen to your Vp? M naught square C square lambda square divided by h square power half, right? So your m naught, when you substitute it over here, so it will become C only. Okay, because this term will vanish. This term will vanish. Okay, so square root of 1 will remain. Square root of 1 will remain. And square root of 1 is 1, so it will be C. Vp equal to C. So electromagnetic, for electromagnetic wave, Vp equal to C. Okay, so Vp equal to C means C is a constant. Okay, what is C? C is basically a constant. Okay, so let me write over here Vp equal to C. That implies that phase velocity is constant. Is constant for phase velocity is constant for which type of wave? For electromagnetic wave, because it is not a function of lambda, it has come out to be a constant. Okay, so what does this imply? This simply implies that Vp is independent of lambda. So free space is non-dispersive for EM wave. So the free space means vacuum. Okay, means vacuum. For electromagnetic waves, vacuum is a non-dispersive medium. Okay, so glass, water, these may be non-dispersive or may not be non-dispersive. We are talking about vacuum only over here. Remember this thing. We are not talking about other medium. Other medium means glass, water. Electromagnetic wave can also travel through glass. Electromagnetic wave can also travel through water. Electromagnetic wave can also travel through alcohol. Electromagnetic wave can travel through anything basically. Okay, except opaque objects. Except opaque objects. Okay, so opaque objects means apardarshi, means like your laptop or your tablet or anything. Those things are what opaque objects, means light cannot pass through it. Okay, but light can pass through glass, light can pass through water, light can pass through ether. Okay, light can pass through some other liquid. Okay, It can pass through honey also, right? So we are talking about vacuum only. So vacuum is a non-dispersive medium for electromagnetic wave. Vacuum is a non-dispersive medium for electromagnetic wave. But it is not necessary that Vp equal to C in a vacuum. So it has come out to be independent of lambda, right? Vp is independent of lambda in vacuum. But it is quite possible. It is quite possible that in water, that in some other, it is, let me write over here. It is quite possible. It is possible that, okay, it is possible that for some other medium, okay, it is possible that for some other medium, it is possible that for some other medium such as water, glass, etc., Vp might be a function of lambda for electromagnetic wave. So in some other medium such as glass or water, the phase velocity may be a function of lambda, okay? But in free space, vacuum, it is coming out to be constant, okay? So, independent of lambda. In free space, the phase velocity of electromagnetic wave in free space is coming out to be independent of lambda, okay? Because there is low lambda term in it. But it is possible that for some other medium such as glass or water, if the electromagnetic wave travels in water, glass, etc., or some other medium, it is possible that Vp may be a function of lambda. Okay. So if Vp becomes a function of lambda, then it is a case similar to de Broglie waves. Okay. So if Vp becomes a function of lambda, then clearly we can say that uh, some other medium may act as a dispersive medium. Okay. So vacuum is non-dispersive medium for electromagnetic wave, but some other medium, okay, so let me write over here, some other medium, some medium other than vacuum, some medium other than vacuum may act as a dispersive medium for EM wave. Okay. Because this formula is valid only in vacuum. Okay. The formula which we have written over here, this formula, okay, this formula is valid only in vacuum. Okay. This formula is valid only in a vacuum. You only write over here. Okay. That the formula, let me write over here. Okay. The formula Vp equal to C multiplied by 1 plus, okay, m naught square C square lambda square, okay, divided by h square power half. Okay, the formula this, okay, is applicable, okay, only in vacuum, okay, is applicable only in free space. That is vacuum. Okay. So in short, whatever I wanted to tell you, I have told you. Okay. So now we will move on towards our next topic, that is de Broglie's interpretation of Bohr's quantum condition. Okay. So may act as a dispersive medium. Okay. Some medium other than vacuum, yes. Okay. So let me write over here now de Broglie's interpretation. de Broglie's de Broglie's interpretation de Broglie's interpretation of Bohr's quantum condition. Bohr's quantum Bohr's quantum condition. Okay. de Broglie's interpretation of Bohr's quantum condition, 2010 question. Now we will see this. 2010 it was asked that how de Broglie interpreted the Bohr's quantum condition. Okay. So Bohr's quantum condition, what is Bohr's quantum condition? Now the question arises that what is Bohr's quantum condition? Okay. What is this Bohr's quantum condition? You have learnt it in the 11th and 12th standard, but let me write over here once again. Okay. So Bohr's quantum condition. Okay. Let me write a language over here. Out of the infinite number of orbits, out of the infinite number of orbits which would be possible, in classical mechanics, it is only possible for an electron to move in an orbit for which the magnitude of its orbital angular momentum L is an integral multiple of h by 2 pi or h cut. Okay. That is, I will explain this now. That is L. And if you didn't understand the dispersive and non-dispersive medium, na, don't worry. Okay, those terms are going to come in paper 1. Okay, so some of the topics of paper 1 are there in paper 2, which are used as a passing reference. Okay, so don't worry that I won't understand the paper 2 if I haven't covered paper 1. It's not like that. You will still understand paper 2, but the only thing is you will have to control your curiosity. Okay, you will get to learn dispersive, non-dispersive medium, everything which I write over here. Some part of it is there in the paper 1. Okay, so let me write over here. Magnitude of L equal to NH cut or MVR equal to N cut, NH cut. Okay, where n is equal to 1, 2, 3, etc. Right? Now let us understand the meaning of this. Okay, Bohr's quantum condition. What is Bohr's quantum condition? Out of the infinite number of orbits which would be possible in classical mechanics. Okay, what is it saying? First of all, read this much only. Out of the infinite number of orbits which would be possible in classical mechanics. Okay, now what does this mean? Let me tell you. Once upon a time, Rutherford had given a theory that there is a solid nucleus and electrons are revolving around this in circular paths. Okay, electrons are revolving around this nucleus in circular paths. This is the theory which Rutherford gave. Okay, Rutherford. Rutherford gave this theory that for a hydrogen atom, according to Rutherford theory, the hydrogen atom was drawn like this, one proton. Okay, like this, he drew the hydrogen atom. Okay, then he said that helium is like this, that two proton, two neutron, and two electron outside. So helium is like this according to Rutherford theory. Okay, and according to this Rutherford theory, it is possible to draw the exact trajectory of a electron. What did Rutherford do? He it is basically classical model. Okay, classical model. So how he is comparing the electron and proton system, electron and nucleus system? How is he comparing? He is comparing it to the solar system. Okay, he is comparing it to the solar system. Solar system means sun is at the center of the solar system and earth is revolving around it. Okay, so sun is the nucleus, means nucleus consisting of proton. Sun is the nucleus consisting of proton, and all the planets which are revolving around the sun are electrons. Okay, earth is an electron, Mercury is an electron, Venus is an electron, Mars is an electron, Jupiter, Neptune, all these are electrons, and sun is the nucleus. Such a model of atom is called as planetary model of atom, and it was given by Rutherford. Okay, we today know this very well. We today know this very well, that according to quantum mechanics, it is wrong to draw the trajectory of a particle such as electron. Electron type particle does not have a trajectory at all. Its trajectory cannot be drawn. I have already told you. According to Heisenberg's uncertainty principle and etc. etc. De Broglie's hypothesis etc. etc. According to it, the path of the electron, like this sharp path of the electron, cannot be drawn. Okay, so according to quantum theory, there is a nucleus and the electron are not revolving in the path. There is only a electron cloud of circular shape. Okay, spherical shape. There is only a electron cloud of spherical shape, and it is a totally probabilistic funda. Okay, it is totally a probabilistic concept. It can't be said that the electron is located here only. Okay, Rutherford said that the electron can be located just like earth can be located around the sun. Rutherford said that electron can be located around the nucleus just like earth can be located around the sun. Okay, so earth is clearly visible around the sun, and we can locate the position of the earth also. Okay, but Rutherford made the blunder that he made sharp trajectories of electrons. Okay, like in the ninth standard you used to draw this like in ninth standard you used to draw like this na. Then lithium you used to draw like this, that lithium consisting of three protons, uh, two neutrons. Okay, and then three electrons are revolving around it. Okay, so like that you used to draw. So that is basically Rutherford concept, planetary model. Okay, so now the blunder is that you said this thing very well. You know, according to classical electrodynamics, it states that, what does classical electrodynamics do? It states states that every charged particle in accelerated motion will lose. According to classical electrodynamics, every charged particle in accelerated motion will lose energy. Okay. Now you only tell me, according to Rutherford model, the electron is revolving around the circular path. Okay. So electron is in accelerated motion, right? Why is it in accelerated motion? You know this very well, that the non-accelerated motion is only possible in a straight line. Okay, only rectilinear motion is possible for a non-accelerated particle. Okay, but the particle is revolving around the nucleus in circular path. As the electron is revolving around the nucleus in circular path itself implies that the particle is accelerated. Circular path itself implies that the particle is accelerated because the particle's velocity is continuously changing. It will be tangential to the circle, right? So it is an accelerated particle because velocity is a vector. So even if the direction changes, suppose magnitude remains same, even then the direction of this vector is continuously changing. It is tangential to the circular path. So direction of this velocity is continuously changing. And as the velocity direction is continuously changing, then according to Rutherford model, the electron is in accelerated motion, right? And if the electron is in accelerated motion, then it should lose energy according to classical electrodynamics. Okay, according to classical electrodynamics, an accelerated particle, charged particle, electron is a charged particle, it has a negative charge. So if it is in accelerated motion, then it should lose energy according to classical electrodynamics. And why is it in accelerated motion? Because it is traveling in circular path, and only non-accelerated motion is possible only in straight line. only straight line में ही संभव है accelerated non-accelerated motion. Okay, only straight line motion can be non-accelerated in this world. Every curved path motion is accelerated motion because the direction of velocity is continuously changing. So in this circular path, the velocity of the electron direction is continuously changing. Okay, while direction of velocity of electron is continuously changing, so the motion is accelerated. And if the motion is accelerated, you only tell me that the electron should lose energy according to the principle of classical electrodynamics. And if the electron loses energy, then the electron must go like this and fall into the nucleus, and both should merge. The proton and proton and electron should fuse. Okay. So this was the main drawback of Rutherford theory. So basically, Bohr gave the quantum condition. Okay, out of the infinite number of orbits which would be possible in classical mechanics. Okay, it is the underlined part over here. So what is Niels Bohr saying? Niels Bohr is saying that Rutherford told that any anapshanap, any random. Okay, Rutherford said that any random any random orbit is possible. Okay, according to Rutherford, if this is the nucleus na, then any random right from here, okay, right from here is like this, there are infinite orbits according to Rutherford. According to Rutherford, any orbit is possible, any orbit of any radius. According to Rutherford, any orbit of any radius is possible around the nucleus. Okay, so electron may revolve in any orbit. Okay, so this is the nucleus. Suppose then electron may revolve here, So there are infinite number of paths possible. In between these two orbits also there are infinite number of orbits possible. Okay, there are infinite number of orbits possible. Okay, so what Niels Bohr did, he said that out of the infinite number of orbits which would be possible in classical mechanics, okay, out of the, what is that, out of the infinite number of orbits that would be possible in classical mechanics. Okay, out of the infinite number of orbits that would be possible in classical mechanics, because Rutherford did not give any restriction on the radius of the orbit. Rutherford did not give any restriction on the radius of the orbit. So orbit of any radius, right from r equal to 0, right from radius equal to 0 up to radius equal to infinity, any radius around the nucleus is possible according to Rutherford. This nucleus, this radius is also possible. This radius is also possible. Any radius is possible. So there will be infinite number of such radius according to Rutherford. Okay. So what is Niels Bohr saying? Niels Bohr is saying that the out of the infinite number of orbits which would be possible in classical mechanics, Rutherford's concept is classical. So it is possible in classical mechanics that there are infinite number of orbits. Okay. So Rutherford is Niels Bohr is basically putting a restriction on it. Okay. It is only okay. What is the restriction with that Niels Bohr is putting? Niels Bohr is putting the restriction that it is only possible for an electron to move an orbit in an orbit for which the magnitude, okay, it is only possible. Rutherford said that infinite number of orbits are possible, r equal to 0, radius equal to 0 up to radius equal to infinity. Any random radius is possible for the electron to move, but Niels Bohr is putting a restriction on it. Okay, so out of the infinite number of orbits which would be possible in classical mechanics, full comma over here. Okay, this is one part of the statement. Now the next part starts. It is only possible for an electron to move in an orbit. It is only possible for the electron to move in an orbit for which the magnitude. It is only possible for, now underline this part. It is only possible for an electron to move in an orbit. Okay, up to here, read up to here. So it is only possible. It is only possible for an electron. It is only possible for an electron to move in an orbit. Okay, so he is fixing an orbit. Okay, मतलब कोई एक ही ऑर्बिट संभव है, ठीक है, कोई विशिष्ट ऑर्बिट ही संभव है, ऐसा कह रहा है वो, ठीक है ना. सो इट इज ओनली पॉसिबल फॉर एन इलेक्ट्रॉन टू मूव इन ऑर्बिट फॉर विच द मैग्नीट्यूड ऑफ इट्स ऑर्बिटल एंगुलर मोमेंटम L, okay, is an integral multiple of h by 2 pi or h cut. So orbital angular momentum L equal to n h cut. Okay, this is the condition he gave, and whichever orbit around the nucleus. Okay, suppose this is the nucleus of hydrogen, right? Suppose this is the nucleus of hydrogen, then whichever orbit, okay, not nucleus, this is the nucleus of hydrogen. So whichever orbit around the nucleus of hydrogen will satisfy this condition, okay, will satisfy this condition L equal to n h cut. Okay, so whichever orbit satisfies this condition L equal to n h by 2 pi equal to n h cut, whichever orbit satisfies this condition. Suppose there is a orbit like this. According to Rutherford, this orbit is also possible. Okay, according to Rutherford, this orbit is also possible in the between. Okay, but according to Niels Bohr, this orbit in the between orbit, okay, this does not satisfy this condition. Okay, so for this orbit which I am shading over here, for this orbit, okay, L is not equal to n h cut. Okay, L is not equal to n h cut. So this orbit is not at all possible according to Niels Bohr. Directly from here, if this orbit, for the first orbit, if it was possible that for this orbit L equal to this, okay, then for the second orbit to be like that, again it will satisfy L equal to this, and n is the principal quantum number over here. So this is n equal to 1. Okay, this is n equal to 2. Like that the orbits are possible according to Niels Bohr. Okay, so according to Rutherford, this intermediate orbit, this n equal to 1 and n equal to 2. So according to Rutherford, this intermediate orbit was also possible. All these intermediate orbits were also possible. But Niels Bohr restricted it and said that the orbit satisfying this condition L equal to n h cut, only those orbit will be filled, and all other energy levels are not at all valid. Electron won't revolve around the nucleus in those orbits which do not satisfy this condition. The orbits which do not satisfy this condition, in those orbits the electron cannot revolve. simply Niels Bohr told this. Okay, so this is called as Bohr's quantization condition. Okay, now you might have learnt in lower classes the L equal to MBR. Okay, L equal to MBR you might have learnt in lower classes for circular motion, right? Now Niels Bohr theory has also been proved wrong, because the quantum theory says that you, इस क्वांटम थ्योरी तो ये बोलती है कि तुमने सर्कुलर पाथ में इलेक्ट्रॉन घूम रहा है, ये बोलना ही गलत है बोलती है। क्लासिकल थ्योरी के हिसाब से सर्कुलर पाथ में इलेक्ट्रॉन घूम रहा है, लेकिन क्वांटम थ्योरी का तो कहना है, नील्स बोर ने तो कम से कम ये कहा था, नील्स बोर ने तो कम से कम सर्कुलर पाथ है ये बात को एक्सेप्ट किया था रुदरफोर्ड के। लेकिन असलियत तो ये है कि ऐसे सर्कल पाथ में इलेक्ट्रॉन घूम रहा है ये बोलना ही अपने आप में गलत है, अकॉर्डिंग टू मॉडर्न कंसेप्ट, जो आज का कंसेप्ट है, जो आज वैलिड कंसेप्ट है, उसके हिसाब से ऐसे सर्कुलर पाथ में इलेक्ट्रॉन घूम रहा है वो बोलना ही अपने आप में एक ब्लंडर है, गलत है। ओके, बट हम तो नील्स बोर की थ्योरी पढ़ रहे हैं, उस जमाने की थ्योरी पढ़ रहे हैं। सो नील्स बोर ने ये बात एक्सेप्ट कर लिया था कि सर्कुलर पाथ में ही हो रहा है मोशन, लेकिन उसने एक कंडीशन दिया था कि वो ऑर्बिट में ही इलेक्ट्रॉन घूमेगा जहां L इक्वल टू एम वी आर इक्वल टू एन एच कट के बराबर होगा। ठीक है ना, सिर्फ यही ऑर्बिट्स अलाउड है, एंड ओनली दीज ऑर्बिट्स आर देयर, ओनली दीज ऑर्बिट्स आर अलाउड, and in only these orbits the electron will revolve, and while revolving in these orbits he also added that these orbits are special, these orbits are privileged according to Niels Bohr. These orbits are privileged according to Niels Bohr, and electron does not lose its energy while traveling in these orbits. So while traveling in these privileged orbits, all the other what will happen in all other orbits? According to Niels Bohr, if this is the nucleus of the atom and these are the various shells in which the electron is revolving around the nucleus. Okay, so according to Niels Bohr, the classical electrodynamics principle, that electron will lose energy and will go in spiral path and will fall in the nucleus. Okay, it will apply to all these intermediate orbits. Okay, all these intermediate orbits, it will apply that the electron will go like this. In the intermediate orbits the electron will go like this and will fall in the nucleus. But for other orbits which are derived from this formula, the orbit satisfying this formula, these will not happen, this thing will not happen, that circular spiral path follow करके न्यूक्लियस में समा गई इलेक्ट्रॉन, ये नहीं होगा। किसके लिए? For whom it will not happen? For these privileged orbits. For these privileged orbits, the principle of electrodynamics, that the electron will follow a spiral path and will fall in the nucleus, this principle of electrodynamics will not hold for this kind of orbits which satisfy this condition. This is what Niels Bohr told people. Okay, so this is very clear now. Okay, so I will write it over here. Okay, hopefully you have now got it. Okay, so let me write over here. Bohr's orbit is non-radiating Bohr's orbit is non-radiating path if the electron, okay, non-radiating path means the electron does not lose energy in this particular path which satisfies the condition L equal to n h cut. The path which satisfies the condition L equal to n h cut, that path is non-radiating path. Okay, and in that path the electron does not follow a spiral path and fall in the nucleus. Okay, it remains in the orbit. It is such a special privileged orbit. Okay, that is what Niels Bohr told the people. Okay, so Bohr's orbit is non-radiating path. Okay, if the electron does not radiate, energy during its motion, in an orbit, so the wave associated with it must be a stationary wave. Okay, so the wave associated with it must be a stationary wave in which there is no transfer of energy. Okay, in which there is no transfer of energy. Okay, further the electron wave can be adjusted around an orbit only when the circumference of the orbit can contain exactly an integral number of de Broglie wavelengths. It means only those orbits are permitted for which. Okay, now I will explain this. Okay, now I will explain this. Okay, so just a second, let me drink water. Okay, yes, so everything is good now. Okay, so Bohr's orbit, up to here we had learned. Now we will learn further that we had learned this, right? That the electron, for example, this is the nucleus. So what I have told you till now I have told you that the if there is an orbit, okay, I had told you just this, that if there is an orbit for which it is not equal to orbital angular momentum is not equal to n h cut, if there is such an orbit, okay, then surely in that orbit the electron will follow a spiral path and will fall in the nucleus. And in those orbits which satisfy this condition according to Niels Bohr, which satisfy this condition, in those orbits the electron will not follow a spiral path and fall in the nucleus, but the electron will keep revolving around the nucleus without radiating any energy. Okay, without radiating any energy, without wasting any energy. So it is written that Bohr's orbit is non-radiating path. Okay, what is written? Bohr's orbit is non-radiating path. Okay, Bohr's orbit is non-radiating path. If if the electron if the electron does not radiate energy during its motion in an orbit, okay, if the electron does not radiate energy during its motion in an orbit, so the electron does not radiate energy during its motion in an orbit. Okay, so that's the thing which has been written, that if the electron while revolving around the nucleus, it does not radiate energy. So it, as it does not radiate energy, you only tell me. So electron around the nucleus, okay, if it is not radiating energy, if it is following this condition, then it is not radiating energy. It means it is continuously rotating, revolving around the nucleus. So so the wave, the wave associated it with it. So the wave associated with it must be a stationary wave. Now understand this concept very well. Okay, why will the wave associated with this, now we will apply the de Broglie concept in Niels Bohr condition. Okay, we will basically apply the de Broglie concept in this Niels Bohr condition. Okay, so as the electron is not radiating any energy, it is continuously revolving around the nucleus in circular path. So basically the thing is that it will have some wave. Okay, because according to de Broglie concept, every material particle has a wave associated with it according to de Broglie. So this electron will also have a wave associated with it, which is matter wave, because electron is a matter. So the wave associated with electron will be a matter wave, and that matter wave will have a wave. Okay, it will have some waveform. Okay, although it is a very abstract kind of waveform, but it will have a waveform, and this waveform must be a standing wave. What do you mean by standing wave? Must be a stationary wave. Okay, stationary wave means standing wave. Standing wave means what? That what, consider an example of water ripple. For the time being, consider a mechanical wave. Okay, although the matter wave is not a mechanical wave, but for the time being consider a mechanical wave. Okay, for the time being consider a mechanical wave. What happens in a mechanical wave? Like this, the water ripples are there in the pond. Suppose there is a pond, and in the pond there are water ripples like this. Okay, so in the pond, if there are water ripples like this, then the water will be like this. Okay, in these waves the water will be contained. Okay, and here will be air, here will be air, here will be air. So here the water ripples are moving forward. Water ripples are moving forward because you had put a stone. You had basically thrown a stone. You had thrown a stone over here. So water ripples had emerged from here, and the water ripples are going forward. Okay, so this is not a standing wave. Not a standing wave. Why it is not a standing wave? It is not a standing wave because it is basically radiating energy. Because from here, where the point where you had thrown the stone, energy is radiated, and these ripples will move forward. Okay, ripples will move forward. Okay, so as ripples will move forward, so it is basically what? It is basically radiating wave. Okay, not a standing wave. What will be a standing wave? Suppose you threw the stone in the pond, and if the water becomes stationary like this, no forward movement. Okay, no forward movement in the water, only the waves remain like this. Okay, then it will be called as a standing wave. Okay, so similarly over here, although it is not a mechanical wave, but it will be a standing wave because the energy of the electron is constant in that orbit. It is not being radiated. So it will be a stationary wave, means a standing wave, in which there is no transfer of energy. Yes, इन विच देयर इज नो ट्रांसफर ऑफ एनर्जी, क्योंकि भाई स्टेशनरी होगी ना भाई आपकी वेव। क्योंकि देखो ना पॉन्ड में क्या होता है, जब आप तालाब में पत्थर फेंकते हो, तालाब में जब पत्थर फेंकते हो तो जो ये है ये रेडिएटिंग वाली वेव निकलती है, ठीक है ना। ये तालाब है सपोज, और आपने यहाँ पत्थर फेंका, तो यहाँ से ऐसी ऐसी वेव्स निकलती ना पानी की, वो कहाँ जाती है, सामने की दिशा में जाती है, सामने की दिशा में जाती है, ठीक है ना। ये वेव निकल रही है पानी की, ये सामने की दिशा में जा रही है, तो ये स्टैंडिंग वेव नहीं है, ठीक है ना। ये स्टैंडिंग वेव नहीं है, ये स्टैंडिंग वेव नहीं है, क्योंकि इसमें एनर्जी रेडिएट हो रही है, ये सेंटर पॉइंट से एनर्जी रेडिएट हुई चारों दिशा में, ठीक है ना। तो ये क्लियरली एक स्टैंडिंग वेव नहीं है, ठीक है ना। बट अगर ऐसी स्थिति होती, ऐसी सिचुएशन होती कि मैंने पत्थर फेंका पानी में, लेकिन ये वेव भी बनी उस पत्थर से, लेकिन वो वेव ऐसी स्टेशनरी है, आगे नहीं चल रही है, आगे नहीं चल रही है। ऐसा मान लो कि टाइम को पॉज कर दिया आपने, टाइम को पॉज कर दिया, तो वेव जो है खड़ी की खड़ी रह जाएगी, वैसी की वैसी। पानी ऐसा था तो ऐसा ही रह जाएगा, ठीक है ना, पहाड़ी की तरह पानी रह जाएगा। सो दैट इज कॉल्ड एज ए स्टैंडिंग वेव, ठीक है ना। तो इलेक्ट्रॉन इज अ what is electron? It is it is in non-radiating motion. So as it is in non-radiating motion, there is going to be no transfer of energy. Okay. So as there will be no transfer of energy, the wave will be stationary wave. Okay. यहाँ पे वेव स्टेशनरी क्यों नहीं थी? वाई द वेव वॉज नॉट स्टेशनरी ओवर हियर? बिकॉज इट वॉज रेडिएटिंग द एनर्जी फ्रॉम द मिडल पॉइंट वेयर यू थ्रू द स्टोन, द एनर्जी वॉज बींग रेडिएटेड इन ऑल द फोर डायरेक्शन. So that's why it was not a standing wave, it was a progressive wave. Okay, but over here the energy of the electron is constant, so the wave associated with the electron will be a stationary wave. Although this is not a mechanical wave, but we can consider the matter wave to be a standing wave or stationary wave, in which there is no transfer of energy because the energy of the electron along the orbit is constant according to Niels Bohr. Okay, so further the electron wave can be adjusted around an orbit only when the circumference of the orbit can contain exactly an integral number of de Broglie wavelengths. Do you get this? Suppose this is the orbit, then the orbit is possible only when the matter waves will complete. Okay, matter waves will complete a complete integer number. Okay, integral multiple. Okay, so half wave is not possible. Okay, so see this, half matter wave is not possible. The matter waves will go like this, come like this, go like this, come like this, and this. So how many waves are there in this? This is one wave. Okay, this is second wave from here till here, this is third wave from here till here. Okay, and this is fourth wave from here till here. This is possible, but this type of wave is not possible according to Niels Bohr. Okay, okay, this is partial only. Okay, so this is not possible. So it must be an integral multiple. So this is what is Bohr condition. So the circumference of the orbit, the circumference of the orbit along which the electron is traveling, it is given by the formula 2 pi r, circumference of a circle, radius r. So 2 pi r will be the circumference of this circle along which the electron is revolving around the nucleus. So 2 pi r will be equal to, I only right now told you that it is only possible if it is integral multiple of lambda wavelength. Okay, so integral multiple of lambda. Okay, where n equal to 1 2 3 etc. Okay, now do not perform this mistake in the exam of writing where n is natural number. Do not write like that in the exam. Okay, only write it is integral multiple, because the person is MSc in physics, he does not know the difference between natural number, whole number, integer etc. He is MSc physics, not maths. He is not a person like me who knows all the three subjects. Okay, so it is quite obvious that do not write n is a natural number. चुपचाप n is an integer लिख के आ जाओ, ठीक है ना, where n is an integer, which integer 1 2 3 and etc. Okay, I know this very well that in the integers negative numbers are also possible. Okay, in integers negative numbers are also possible if you look at pure maths. Okay, but we don't have to go into those things. We have to simply write that it will be integral multiple, because the person is MSc in physics. He is not a person like me who has the knowledge of all the three subjects PCM. Okay, so you will write. Now I will write the now write in the notebook. Now write in the notebook after this. Okay, integral number of de Broglie wavelengths. Up to this you had written in the notebook, right? Now write in the notebook after this. After this, it means that it it means that it means that only those orbits are permitted for which the radius r is given by, okay, the radius r is given by 2 pi r equal to n lambda. Okay, only those orbits are permitted for which the radius r is given by 2 pi r is equal to n lambda. Okay, so do not write that n is a natural number. Integral multiple only you have to write. Do not write a natural number multiple, okay, in the exam. So where n is 1 2 3 etc. Okay, now lambda equal to h upon p, okay, which is equal to h upon mv. Okay, so you know this very well now that 2 pi r is equal to n lambda. We found out that only integral number of some full figure number of lambda will be equal to the circumference of the orbit, right? So you know this very well, na? From this, because this is the circular path, suppose. So if this is one wavelength, okay, so this is lambda, this is 2 lambda, this is 3 lambda, and this is 4 lambda, right? So like that you will have full figure lambda. This is lambda number 1, so 1 lambda. This is 2 lambda. This is 3 lambda. This is 4 lambda, right? So n lambda will be equal to 2 pi r, like that. Okay. Now lambda equal to h upon p. Lambda equal to h upon p, right? So it will be equal to h upon mv, right? H upon mv. So put this value of lambda over here. Okay. So you will get 2 pi r equal to n lambda means nh by mv. Okay. nh by mv. So your mvr will come out to be what? Your mvr will come out to be nh by 2 pi. Your mvr will come out to be nh by 2 pi. Okay. So that is how you got the Bohr's quantum condition. You got Bohr's quantum condition from starting from de Broglie hypothesis. This was what? De Broglie hypothesis. Okay. This was de Broglie hypothesis. And starting from de Broglie hypothesis, you reached up to Bohr's quantum condition. Right? So in this way, you have to proceed. So now you got this, na? MBR equal to NH by 2 pi. So this in turn implies that magnitude of orbital angular momentum. This will be what? Magnitude of orbital angular momentum, right? L equal to mvr, the formula of nursery. Okay. So n h cut, right? This is what is Bohr's quantum condition. This is Bohr's quantum condition. Okay, so starting from de Broglie hypothesis, you got the Bohr's quantum condition. Okay, so now I will basically drink water and come. Okay.